we're going to get started with Mike's talk. And so now, if you all don't know Dr. Brady, he's an assistant professor and extension economist in the School of Economics here at WSU. And Dr. Brady focuses on specialty crop production, including tree fruits, vineyards, vegetables, horticulture, and nursery crops. He also has an interest in issues related to water use and integrated ag. Dr. Brady is involved in a number of projects focusing on modeling coupled human and environmental systems in an interdisciplinary framework, and he's also analyzed the economic impact of various ag industries in Washington and conducts research on farmland ownership, ag land values, and land use change. So
that was a generous introduction. So I just give you the nod for next slide, or is there?
I'm sorry, I didn't even give it.
Oh, is it right?
Yeah, and I didn't put the USB back. So this is laser pointer, and this is forward and back.
Okay, all right.
Sorry about that.
All right, well, thanks for having me. I know some of you, but not familiar with a lot of people in the room. So I'm going to focus as much as I can on water rights. I think that's the issue that's sort of always lurking underneath all this work we do about particularly adaptation to climate change and impacts of climate change. So I'll talk some about economic modeling in general, but that's to sort of motivate the questions of how water rights influence adaptation options. Just a little background on the projects I've worked on in the past. Related to this, there's the State Department of Ecology forecast. We're right now involved in a review of the Yakima Basin Integrated Plan, which is why this is going to be a bit Yakima Basin centric, but I can talk a little bit about that. And I actually think I finally made a presentation short enough to actually leave time for questions, which I usually fail to do, but I think this time I've done it. So I think we have 45 minutes, so I'm going to try to actually get in it at half an hour, because usually when it comes to water rights, there's lots of questions. Whether or not there's answers is a whole other question. So here's the basic, the way we kind of do modeling. So I really should have had biophysical system here. So at least for the people on campus, if some of you know Jenny Adam and Mike Barber's now at Utah, but folks over in civil environmental engineering work with folks at UW who do a lot of the climate change modeling and then the downscaling and modeling the hydrological systems with various models with great acronyms. Engineers are really good at acronyms, I've learned. On this side, though, we've got individual water rights, individual water use decisions, right? And there's a lot of feedback through return flows, timing of diversions, all that sort of stuff, and it all goes through here, which I didn't make a black box, which I thought about doing, but we know a little bit, so now it's a green box, not a black box. But this really does complicate, to an incredible degree, modeling the physical system, the individual water use decisions, and the interactions between the two. I've been working on this in Washington for 5 years. It's really taken about that long to really figure out how it all comes together and how water rights dictate how you can model these and think about things like adaptation. I figured you'd cover this, but obviously snowpack, the concern with climate change, reduced snowpack, increased rain on snow events. So that reservoir of snow that helps in the summer, the concern is obviously that it's going to be getting smaller. Increased curtailments for out-of-stream uses is the implication. Let's look at some actual numbers, though. So as I mentioned, this will be do a lot of work outside of Yakima, so if you have questions, feel free to have them not just be Yakima focused, but at the moment this is where we have a lot of good information. So let's just look back at the historical curtailments, what's actually happened. So these are all the years in which there were curtailments. I'm sure a lot of you know the big ones were 92, 93, 94, 2001, and 2005. Those really got people's attention. So if we look here, the sort of generally accepted in people's mind, what's been the biggest curtailments about? So 30% of normal diversion of entitlements. So each irrigation district has an entitlement. The proratable water rights holders have been prorated to 30% of their normal entitlement. So that's what these numbers mean, and that's usually how it's phrased. So, and this is Yakima Basin wide. Obviously, there's a lot of difference across the districts. And if you have any questions about this, it's fascinating. Sunnyside district is quite a bit different than Rosa. Rosa is 100% proratable. Sunnyside is 31% proratable. Wapato is about 50%. Kittitas is 100% proratable. So this is basin-wide. It's really different if you're in Sunnyside than if you're in Rosa. Sunnyside has really never been curtailed. Rosa has been.
Why is that?
Because of the water rights percentages. So Rosa is 100% paratable. Because of the Sunnyside's older, so first in use, so it's prior appropriation. So Sunnyside comes first. They have, and this is where it gets complicated, is that Sunnyside is 69% non-proratable. Rosa is 100%. So the way the math works out, roughly, is that you would multiply that 31% in Sunnyside times the percentage, the prorationing, so times 0.3, so 0.31 times 0.3, and that would be the reduction from Sunnyside's entitlement. But they do some things so that they essentially don't have to curtail anyone in Sunnyside. In Rosa, they're 100%. So you're 30% of Rosa's entitlement, which is like 160-some thousand acre feet. So you're just 30% of that. An important fact, though, too, within Sunnyside is that there's no difference between proratable and non-proratable rights holders in Sunnyside. During the adjudication, they all came together and just pooled them. So it's district level. So there's not proratable and non-proratable rights holders within Sunnyside. There used to be, but there's not anymore. That's the outcome of the adjudication. And then in Wapato's, Yakima Tieton, actually, they've reduced how much water they use, and they say that they don't really, a drought really wouldn't affect their ag production. So, but these are the sorts of numbers you see, and that's what they mean, and that's initial hint to how this gets complicated really quickly. Just to put it in scale, and these are from estimates from the previous reports on the Yakima Basin Integrated Plan. So here, the red are their entitlements. So Wapato's got the largest entitlement. In a drought year, this is if you made that calculation, say it's a severe drought, so they only get 30% of their entitlement, times the proration percentage in that district. That's where you're at for Rosa. That's where you're at for Sunnyside based on their historical diversions. As you'll notice here, they don't, in typical years, they don't use their full entitlement. So there is some room there. So this is why it's just a very different situation in Rosa during a drought than Sunnyside, even though they're right next to each other.
Does that reflect in land values or Sunnyside land values? Land values higher, I would assume.
That's a great question. So Joe Cook over at UW in the public policy school, he's working with us on the integrated plan project. He had a student who did a we call hedonic model of using market transactions of land sales in the different districts to see whether or not what the value of having a non-proratable right was. And John Yoder's working with him to kind of help move that paper along a bit. And so that analysis has been done because that's a good question. That's another way, though, to also get at the benefits of some storage project is to use land values. You can do it all based on sort of production numbers. What's the value of production in a non-drought year? What's the value of production in a drought year? And the difference is the benefit of some storage project that allows you to not have to curtail producers. The other way is to use land sales where buyers of land, they price that into what they're willing to pay. And that's another way to get at the value of some sort of like a water storage project. So here's where it gets complicated when we think about adaptation. It's just here's the list of things that any farmer in one of these areas could do. Right? You could change your irrigation system. You can change your crop mix. You can fallow acres. You can deficit irrigate. You can fine-tune irrigation scheduling. In economics parlance, we say that you're substituting labor for water. You're spending more time to get more out of your water. You can do that to a point. One that has been thrown out there a bit is weather insurance. These hasn't been used a lot, but in other parts of the country, like what happened with Hurricane Sandy and other, there's some question of whether or not like a snowpack indexed weather insurance instrument would be the best option. So that's being considered. It's a bit complicated to consider as all of these storage projects are also being considered for obvious reasons. There's a lot of groundwater, right? That's why California's production hasn't dropped off that much this year, because they're pumping loads of groundwater. So our vegetable prices haven't increased as much as we may have thought. And you can also trade water, which is, of course, what the economists always want to spend all their time thinking about. But I'll talk about why that's, as we know, is not so simple. But I should say that this is why it gets really complicated. You could write some mathematical model of production. What's the optimal? Right? We could write down some horribly complicated dynamic optimization model that factors in all of these things and perfect. It's stochastic, but you have some sort of expectations of the future. There's a lot of the math could go on for pages. But as we know, farmers are using rules of thumb. They know some things better than others, and so you want to capture what really goes on. So that's where the difficulty comes. You could write a model that does all this, but you want to capture real behavior. But there's so many choices that can be made for adaptation. So when you look at what's the effect of a drought, you want to capture adaptation, but it is complicated. I do want to focus, because it's a livestock focused group, there is this really interesting interaction with adaptation that really gets at forage and feed production. But before I get to that, to talk why that matters, I'm just going to work through sort of what we call let's just run through the simple frictionless model for farm level response to a drought. Okay, so you just basically set up a simple constrained optimization problem. Farmers seek to maximize net revenue. They have a limitation on land and water. In a non-drought year, the land constraint's binding. Why? Because water rights restrict the number of acres. There's no spreading, right? So you can only irrigate so many acres. Usually those water rights are generous in terms of how much water you need per acre. So what's the value of an additional amount of water? Given the land constraint, well, it's zero. No farmer would be willing to pay for more water in a non-drought year. In the drought year, the land constraint's not binding, the water constraint is. That's the basic idea. As is the case with all economic models, we're always looking at the margin. So what's the value of an additional unit? What's the cost of an additional unit of water? And so when we talk about value of water, that often gets, it's hard to know what's being referred to as. Is that the cost of water? Is that the capital cost, the pumping cost? What we're usually talking about here, the value of water, is the value of an additional production, the value of the additional production made available by an additional amount of water. So that's the real definition of value in this case. So let me just run down to here. So you can run through the math on this sort of thing, but you're going to maximize profit where the additional value of more water is equal to the cost, the per unit cost of that water. So this is the point I like to try to make, that you only irrigate to maximize physical production if water's free. If water's not free, from a pure profit maximization standpoint, you never want to maximize the actual physical yield, right? Which makes the idea of deficit irrigation sort of a radical departure kind of interesting. And as I mentioned, the marginal value of water in a non-drought year would be zero because you can't spread. There were some cases with spreading going on some years back, but try to crack down on that as much as possible. Okay, so what about in a drought? Let's just take the simplest case of farm level adaptation. So no long run adjustments of irrigation technologies, because this is, you don't know there's going to be a drought year and then one happens. So let's just imagine there's 2 crops on the field. What is the basic adaptation response look like? Well, we can use some quick picture here, and this pretty much captures all of it, right? So diminishing returns from water. You get the biggest jump in production. As you approach the maximum physical yield, it starts to curve down. This looks a little different for different crops, but more or less that's the same. What we do here, though, is then the dollar per acre foot, so the value of an additional amount of water, is then the change of this graph multiplied by the price of the price of the output. So it's a downward sloping curve. So let's imagine we've got a high value crop, which we've got a few acres of, and a low value crop you've got some more acres of. So this is the high value crop. And then this is the low value crop. So when you don't have any water and you give that first amount of water, you're going to send it to the high value crop. Okay. And then this is your water constraint in a drought year. Could you irrigate these to maximize physical production? Let's just assume water's free. Well, this plus this is greater than this. So no, and that's basically the situation that, say you've got apples and wheat, right? Well, the little trick to show this is if you take this side here and flip it, what's the allocation of water across the high and the low value crop that maximizes profit? It's where they intersect, right? So underneath all of the economic models for modeling climate change and adaptation, this is essentially kind of it. There's a lot more, but that's the kernel of what's underneath all of the economic models to look at climate change. That's how you model adaptation. And the reason, what you want to avoid are some analyses where you don't consider any adaptation and you just curtail all crops. That's the Robert Mendelsohn at Yale. That's the example he gives. You're sitting on the beach and the tide's coming in and you don't move. That's the approach you don't want to do to modeling climate change, because that, you're going to move back on the beach and not drown. So, and this is farm level, right? So as long as you have a diversity of crops, any farmer can do this. You don't have to trade. So this is sort of you would at least do this, right? This is sort of the first cut. And this is what we call a short run response. Short run response is no changes in fixed costs or capital, things that are multi-year, you can't change in the short run. So cropping patterns, you can fallow acres. Like I mentioned, you can spend more time on improving irrigation. In a drought year, typical manager will spend more time out there taking soil moisture tests and trying to adjust their irrigation scheduling. Trading can come in terms of leasing water. And that does happen, let's take Yakima for an example, between Rosa and Sunnyside. So in previous droughts, Rosa has bought water, leased water, not a permanent sale, but leased water from Sunnyside. The way it happens is the Sunnyside Irrigation District manager goes around and asks anybody in his district if they're willing to fallow some land to allow the water to go to Rosa. And typically what you'd expect is that the water's going to pull off low value crops and it's going to go to apples, cherries, that sort of thing in Rosa. And that is what's happened. In 2001, that's what happened in 2005. I think about 30,000 acre feet.
A question on just that scenario you were talking about. So then the owner of that water right is the irrigation district and not the individual entities that use that water. So there's no overall concern about loss of water right?
So this is a great point. This took us forever to figure out, and not until we went and met with them did we really feel like we fully got a handle on it. Just take the Rosa Sunnyside. These have to be negotiated through the irrigation districts. Individual A in Sunnyside and individual B in Rosa cannot negotiate on their own to trade water. It has to go through the district managers offices for that transaction to happen. Yeah, because, and I'll mention this a little bit, but what makes water markets so difficult are the third-party effects. You move water in time and space, which affects return flows, and anybody in between who's subject to in-stream flow limits. If you're, say somebody downstream sells to somebody upstream, so rather than the water coming down the river where there's an in-stream flow meter, they sell it to somebody upstream, they divert the water out, which pulls down the river, and if you're in between there, that's what we call a third-party effect, and that would, and just that, the Yakima Basin Integrated Plan, the previous reports, the way they model adaptation is they take a conservative approach in that they only consider short run. Fallowing is the only adaptation, right? So there's no deficit irrigation. As we say, all the change in irrigation happens at the extensive margin, so the number of acres irrigated, not how much each acre is irrigated. So that's an important modeling choice. You can see why people make it. Because for example, I've been working with Jenny Adam and Claudio Stockel for a year and a half on using Claudio's model to map out these curves. And it's a lot of work to get to see what these yields are for different crops at varying locations and varying irrigation intensities. So there's a reason why that assumption's made. So getting back to the interest here is that what this model would show you is that crops used to feed livestock are likely the ones they're most likely to be fallowed if you use the value of the marginal product of water as we put it. And I'll show the next slide. The question though is this how it really plays out in the real world? And when we sent a page and a half of questions to the district managers, and they said it would take 50 hours. We got a lot of information from them. But I do appreciate, though, them trying to communicate the complexity of how to actually do this in a drought. So for example, Rosa, these are numbers that were used in the previous integrated plan study. So this is the dollar per acre foot. So this is the value that you would expect someone would be willing to pay for water by crop. And they use district-specific yields for this. So you see, though, the difference in apples at $401 an acre foot, and some other crops more around around 100. And this is the acre feet of water used. So here's a graph of that for Rosa. So if you plot this side, the lowest value crops and the number of acres, this is how, if you start having a drought where you're moving the per rationing level this way, this is how much you'd expect someone this is what you'd expect the price to sell water from Sunnyside to Rosa to be. As the drought gets worse, they're threatening higher value crops, and the amount that they're willing to pay goes up.
Can you sell the water if you're doing, say, if you go to a lower irrigation, like drip irrigation system?
No. So yeah. So this is
Makes sense.
this is an.
That represents water spreading if you do that. Is that correct?
Yeah. Right.
Okay.
So this is a really important part about water rights is that your right is over diversion quantity, not over consumptive use. However, when you trade, typically with trades are over consumptive use. Now, historically, why did they do it over diversion quantities? Consumptive use is ultimately what matters. Well, it's a measurement problem. 80 years ago, there's absolutely no way they're going to measure consumptive use. Even now, maybe, between remote sensing data and all sorts of other things, you could back out consumptive use. But and it's also different Yakima is also a bit different than the rest of the state on this because of the way the districts are and the Yakima adjudication affected some of these things. But right, because that's how much water does this crop really need relative to this person's water right. And if there's a gap there, should their water right just be this now because they switched to an efficient irrigation system. So they've given up essentially an option value on their water right. So, and actually I'll get to an analysis I'm working on now trying to look at this. The export market, if you deficit irrigate Timothy, you get intrusions of bluegrass, and that will not fly in South Korea, Japan. It all gets sent back. So that's why they're less likely to do something like deficit irrigate. Then let's take corn silage, right? That price is derived from the value for dairy. So it's not just, you'd really have to model the dairy industry and substitute feeds, which you all know a lot more than I do, and how much, to the extent which you can substitute feed and how much they'd be willing to pay in a drought for corn silage. And then specifically on water markets, why are water markets, even in places where you have a drought, they're difficult? Well, third-party effects, and like I mentioned, the difference between diversion quantities and consumptive use. So water markets get difficult. However, if you look at areas that have worse water scarcity problems than us, because we do hear sometimes, I wouldn't sell my water for anything. It's a lifestyle choice. Well, if you look at Colorado and Arizona and Southern California, where there's water scarcity problems are a lot worse, there's a lot more water being sold. So, what would really happen if the problem got a lot worse? So quickly on that, so the empirical analysis I'm working on now is to actually see, do we observe how much more likely or how much more frequently do we observe efficient irrigation systems in Rosa than in Sunnyside? Right, because there's been, and this is sort of a proxy for climate change is the way I'm thinking about it, is that, there have been some droughts. They've been somewhat frequent, somewhat severe, but not, like California. So when you think about subtle changes in climate change and increased curtailments, what's the effect on, how much more likely is efficient irrigation adoption likely to be an adaptation tool? Well, I found about controlling for as much as possible, it's about 5% more likely that you'd see an efficient irrigation system in Rosa. And so I'm also then doing something on wine grapes. Wine grapes, I think, are potentially a huge adaptation strategy because the district manager in Rosa took us on a tour, and some of their wine grapes growers, they're down to 12 to 18 acre inches of water a year. They get the best quality by almost killing the plant. So they're way down. So if you mix in wine grapes, given the fact that you don't get a diversion in your right, if you put on a crop that uses less water, you mix some wine grapes onto your acreage during a drought, well, that may help you absorb the impacts of a drought.
Okay, so again, you get a diversion, you don't get a amount of consumption. So if you were to go to wine grapes from alfalfa or just whatever,
Yeah.
and you're using a third the amount of water or something like that.
Do you have a change in your water right?
Yeah. What happens to the rest of that water? It just doesn't get used?
Right, that's that graph I showed with the bar charts. That's why now the typical use is less than the entitlement. And if you look at the annual water use in these districts over time, it's been going down in a typical year because of irrigation technology, crop choices. So they've been using less water over time.
So is the idea there, if I use less on part of my farm, like by putting in those grapes, I could use more on another part?
Right,
Is that correct?
right, yeah.
But as long as there was a big.
As long as it was already being irrigated.
As long as it's already
because
been irrigated.
That's where there was a lot of people got upset about this years ago, about this whole water spreading controversy
Yeah.
and so forth. They said, look, we have a water right for this many acre feet of water. And they said, we've adapted to increased efficiency of irrigation, and so we have an excess water right available to us, and there's an adjacent circle, here's 600 acres adjacent to us that I can now irrigate that hasn't been irrigated before. That's prohibited.
Yeah.
So you can't take the efficiencies you gain and spread it to land that hasn't been irrigated, and
That's crazy.
just drives some people crazy.
It is crazy.
Yeah, but the beneficial use provision, while you can on one hand see why it's there, it creates incredibly bad.
Of inefficient systems, and you're
Yeah.
allowing that to drive current policy and current production practice. That's not.
Yeah, because you talk about all the, it's hard to avoid the fact of, how the threat of a drought in this area, and then you go drive through and you see real irrigation, wheel line, trying to square those two things, well, you really have to get back to water rights. So trying to actually do this is using the WSDA cropland data layer overlaid with the parcel ownership GIS layers as well to look at crop mix by landowner. Yeah, so I think I
Well,
mentioned
it-
this.
It makes sense. It makes sense why Rosa has higher efficiency.
Yes, yeah. So the motivation for this is that if you go back to that slide I had where there's this laundry list of adaptation strategies, we're trying to make the modeling as realistic as possible. But like I said, we could write this horribly complicated mathematical problem, which probably isn't realistic in some ways. The way on-farm decisions are being made, they've plenty of demands on their time. They prioritize some things over others. So the way to really back up any sort of prioritization of adaptation responses is to try to do as much empirical work as possible to really see, okay, well, what do we observe in terms of crop mix choices versus irrigation technology choices.
You talked about sort of leasing or one-time sale of water rights, say within Sunnyside,
Mhm.
Rosa. I'm up in the Okanagan, and from what I know, what I've been told, there's a lot of parcels along the Okanagan River that used to be in small orchards, often in a frost pocket,
Yeah.
where that land no longer has water, and now those water rights have been permanently moved downriver to other land.
Yeah, permanent sales, right. So the permanent sales
Now,
is
also,
another
you
question.
can't move them upstream, they only can be moved downstream, is that correct?
Yeah, because that's the third party effect. That you can't harm another water right user. So it's much easier now. What do they never have upstream sales? They may be able to have some sort of additional work done that would be allowed.
So how does that happen? Do districts negotiate those sales?
Yeah, I did a 3-hour phone conference about 2 or 3 years ago with district managers from all over and asked these sorts of questions. And it's about a 10-page notes from that meeting. And we asked the sort of question, what do you do when there's a curtailment? How do you actually go out, send out letters? How do you enforce these things? And each response is different. You get the sense of how much sort of on the ground one-to-one interaction actually actually drives water use in terms of stopping people breaking the rules or not breaking the rules or stopping people or what all is actually done. But the different districts, they're each different. Yeah, and the water rights, they're individually held, and we know this in a lot of areas where, particularly with crops where you need that downstream processing. So you really need to maintain the critical mass of production, because you know the numbers for processing facilities. They'll tell you this is the amount of production we need to be able to run through this plant, whether it's potatoes, apples, whatever, to run through this plant. And if enough people sell their water, you're going to go from this amount of production to that crop, and then it'll drop off a cliff because you will lose that the processing. Right, yeah.
In your two districts, you talked a lot about Rosa and
Sunnyside.
And I know some districts have invested a lot in infrastructure, and so instead of having open canal type ditches, they've actually put that all in
Rosa's
pipes or underground, or so. Where are those two districts at in that?
Rosa has done a ton. Rosa has almost just piped their whole system. Okay. Yeah, we actually went to go around and look. Sunnyside has, and as Rosa will tell you, they've done it with their own money, which is true. Sunnyside has used a lot of the federal government's, I don't know if it's technically EQIP type policies, but Rosa has put a lot of their own money into their infrastructure and really to increase the efficiency. Now, it's always a little bit, you always want to keep in mind the return flows. And if you, which makes the issue of efficiency, the policy that would benefit everyone to respond to climate change would be policies that increase efficiency. When you overlay that with the rights being diversion quantities, Norm Whittlesey did a lot of work on this 10 or 15 years ago. Some of you may know him in our department, that you will increase the scarcity problem if you leave water rights over diversion quantities, but then strongly incentivize efficiency in a drought. You actually exacerbate the problem. You don't make it better. So if you just leave everything else the same, but put in strong incentives for on-farm or efficiency or leaky canals in a drought, you can actually make the problem worse, because you'll increase the consumptive use in that one district in a drought, and then you'll reduce return flows. And that'll build down the system, and the water levels will get lower and lower relative to what they'd be otherwise. So you really have to be careful with those efficiency incentives.
In swim where I used to live, they've done a huge amount of efficiency piping of ditches and so forth, and just gone to more efficient models. And that, it's actually the oldest irrigation system in the state. And now what's happening is hundreds and hundreds of private wells are failing because they had a false aquifer that was basically been fed by a 120-year-old irrigation system that was very inefficiently. And so there's lawsuits now, people are suing the irrigation districts because they had a 40-foot well that's failed, now they gotta go 250 feet to find water, and so forth. It's a mess.
Well, so the big one on the east side is Kittitas, the exempt well moratorium in Kittitas County. So in 2009, I think, and then officially in 2011, there was the exempt well, that you could, if fewer than 12 houses per 40 acres, they could drill a well and not have to get a water right. The moratorium went in 2009, that's done. And I know the county commission there has complained that it's hurt development. We're trying to look at the effect that had on land values to see if it sort of makes sense in the development right there, but that's on the east side, the well issue. Because that's also the surface and groundwater are tightly coupled there, and those problems are worse when they are. So, yeah, interesting problems all over the place. Yeah.
Did anybody hear the story on NPR a couple weeks ago about the drone use in California? What was that crop? Was it almonds? Anyways, there's people interested in getting drones for agricultural use to monitor where their irrigation losses. The system costs $15,000, I think, but they say the drone can cover in a short amount of time, maybe 4 hours, what it would take their people on the ground to cover in a week.
Yeah. So this is I think one of the biggest issues is that historically, if you look at a lot of the decision support tools that were put out, 5, 10, 15 years ago, was sort of an engineering focus. They required enormous amounts of information from the farm manager, somewhat unrealistic amounts of. You'd have to spend a lot of time doing testing to get that amount of data to put in to optimize your irrigation system. But there's one farmer on our advisory group for one of our grants, and they're going to put in smartphone-enabled probes just all over the field, and just automate the whole thing. And the amount of time, management time, that will be required to improve that efficiency, I think we're just about to shoot right up. Well, I should say the cost will just rocket right down, and the ability to improve efficiency with drones or with sensors that fully automate everything.
What's the incentive to do that if you've got this much water?
Yeah.
You can't spread the water you're saving anywhere else. What's the incentive to do that?
So the early adopters they're yield related. There's enough positive yield effects because if you've got uneven terrain to avoid pooling of water and yeah. So well, if you're in Rosa,
a significant amount of water you're not using, and you can't use it elsewhere. It can't be in other words, it seems there's a disincentive to get very
In this
efficient.
story, it was in California, he's charged for the water he uses. So he's saving it.
California, so California made a change. They made a change to their beneficial use provisions in California. I'm not an expert on California's water law. I don't know exactly what it is, but they did change the beneficial use provisions to try to remove the incentive to be inefficient. So that is a different situation in California. Now, take a grower in Rosa who doesn't want to have to try to buy water or not have anybody be willing to sell water at a price they'd be willing to pay from Sunnyside. Then depending on the crop, that sort of a system, see if it pencils out. But you'd want to be able to in the drought, be able to not to maintain production at those lower water levels. The return on that investment depends a lot on how frequent and how severe you think droughts are going to be.
But in a good year, you just got extra water.
Yep.
You can't be compensated for it.
Yeah. Put in wine grapes. Every acre of wine grapes that goes in represents
So I guess part of the question then, do you see over time, like the water rights, so if let's say you gain efficiency, so maybe you could add another 100, 200, 500 acres with the efficiency. Do you ever see that policy changing so we can use water on that?
So irrigating more acres in a, that seems highly unlikely, that we will see a significant increase in irrigated acreage.
Is that near term, long term, forever?
Long term. I think they're so focused now on being able to irrigate the lands that have a right to be irrigated in a drought. That is clearly the focus, even long term. That the idea of how can we change water law to irrigate more acres in a non-drought year isn't on the playbook. Yeah.